Okay, so we've got to do at least one more video involving factoring. And if we need more stuff after that, and more topics for the test, we'll prepare for the test eventually, hopefully. But this will be factoring. I believe we're up to D, if I'm not mistaken. Okay, let's practice another one of the type that I just showed you in the previous video. And here's the example. I'll call it 1 on this video. It is 6. We're supposed to factor 6x squared plus 23x plus 23x. So you can see live again how, or on this video, how a situation where you do not have a coefficient of 1. What do we have over here? We have a coefficient of 6 next to the x squared, not 1. So it's not the easy situation where you just solve the riddle. We have to do more. Part of it is to solve a riddle, but we have to do more. So let's try to do it almost exactly the same way we did the previous problem. Put the scrap paper over here. Step number 1 is to take the coefficient of the x squared and multiply it times the last number, which has to be a constant. You have to put it in order. If they play a trick on you and don't put it in order, you make sure it's in order. First the x squared, then the x, then the number. Or first the y squared, then the y, then the number. If they play any tricks. Anyway, this is in proper order. 6 times 7 is 42. Put it over here. And the middle coefficient is 23. Put it over here. Let's solve the riddle of what two numbers are. A times b equals 42. And a plus b is equal to 23. Those two numbers are, and not so easy to figure out, 21 times 2. 21 times 2 will get you to 42, and 21 plus 2 will get you to 23. So the magic numbers are 21 and 2. Now remember what we did. We said leave 6x squared alone. We also said leave 7 alone. But now break up 23x into 2 parts. Which 2 parts? The magic numbers. Turn 23x into 21x plus 2x plus 7. So we didn't do anything illegitimate. We changed 23x into 21x and 2x. It's the same thing as 23x. As soon as you get those 4 terms up there, split it down the middle and factor by grouping. That means get the GCF of the left binomial. What number goes into 6 and into 21, the highest number you can think of? Answer, 3. What x goes into x squared and x, the smallest of the x's, which is 3x. Go over to the right side if you need to. Sometimes you can just do this in your head. But if you need to, you go over to the right side, do the scrap paper, 6x squared divided by 3x, and 21x divided by 3x. 6 divided by 3 is 2. X squared divided by x is just going to be plain x, 1x, x to the 1 power. X and x cancel. 21 divided by 3 is 7. Here's what goes over here, 22x plus 7. Move 2x plus 7 over here without even thinking, because that's the only way it's going to work. Surrounded with parentheses. Now look from bottom to top. How much do I have to multiply 2x plus 7 to get back to 2x plus 7? Answer is just plain positive 1. Everything is done now. Put 1 copy of 2x plus 7 in its own parentheses. Take the 2 leftovers, put them in their own parentheses. 3x plus 1. The plus 1 does not disappear. You need it. And here is our final answer. And maybe on the answer sheet they will say 2x plus 7 first, and they'll have 3x plus 1 over here. And that's the final answer for problem number 1, a problem just like we saw in the previous video, the last one in the previous video. Okay, now we've got to look at a little bit more about factoring. There's something called a perfect square trinomial. We're still dealing with factoring, but I'm just going to cordon that off and write the name perfect square trinomial. Perfect square trinomial. And let me show you what the symptoms of a perfect square trinomial are. Okay, first let me move the paper up, just in case we need more space, which we probably will. Okay, let me call it problem number 1. And we need to factor it. And here it is. X squared plus 8x plus 16. Now, You could go back to the first video right before this, and you could look at the method that when you have x squared, when you have x squared, plain x squared here, plain x squared with a x squared meaning that the coefficient is 1, then all we got to do is solve the riddle. Put 16 on the left, put 8 underneath it, two numbers that multiply to get 16, and they add together to get 8. But here's how to tell whether you have a perfect square trinomial or not. Take the square. It looks like there might be a perfect square trinomial. You'll see that this is easily. I can take the square root of this. I can take the square root of this. Well, let's do that. Take the square root of x squared, you get x. Take the square root of 16, you get 4. And if you can, if you multiply this 2, what do you get? You get 8x. You get exactly the middle coefficient. So if you take the square root of your left term and square root of your right term, and you multiply it by 2, and you get the middle term, that is a perfect square trinomial. Those are the symptoms. If you can take the square root, multiply it by 2, and you get back to the middle, that brings you back to the middle term, that is a perfect square trinomial. And you do not have to even think about how to factor this. You don't have to do it. There's a total shortcut. You put the square root of x squared is x. The square root of 16 is 4, positive 4. And the answer will, and then you do 2 copies of it, and it is factored. So the answer is x plus 4. 2 copies of that means x plus 4 squared. Here is the final answer to this problem. Let me show you another perfect square trinomial. The other type, x squared minus 8x plus 16. Now you can see you can take the square root of x squared, you'll get x. Take the square root of 16, you'll get 4. Looks like something is special going on over here. So let's do that. Take the square root of x squared, which is x, the square root of 16, which is 4, and if you can multiply it by negative 2, either 2 or negative 2, that's the only way back to get back to a perfect square trinomial. Either being able to multiply those two by 2 or these two things by negative 2. Let's see what happens. I can see I need a negative. Over here I was all positives, so we were fine. Over here I see I need a negative. Multiply x times 4, you get 4x. 4x times negative 2 is equal to negative 8x, and you get right back to the middle. It's another perfect square trinomials. You can have it in positive form or in negative form. Positive form you multiply by 2. Negative form you multiply by negative 2. Gets us back to the middle. As soon as you see that, you know that you have, take the square root of x squared, you get x. Square root of 16, you get 4. And you're going to have another copy of those, but what do you put in the middle? A minus this time. And therefore, the answer to this is, factored, is x minus 4 squared. And this problem is over. Okay. Now, I have some room here. I want to show you a problem where you can still see those two. What if you have a problem that looks a little complicated? Problem number 3. 4x squared, let me slow down here, minus 28x plus 49. Do we have a perfect square trinomial here or not? It looks like something's up here. 4x squared, take the square root of 4x squared. Square root of 4 is 2. Square root of x squared is x. Okay, that's the square root of 4x squared. Take the square root of 49. It's a perfect square. Square root of 49 is a 7. What's that all together? 14x. If I multiply by negative 2, 14x times negative 2, I get negative 28x. It's got all the symptoms of a perfect square trinomial. This is a hard problem to do. This is not an easy one. The coefficient of x squared is not 1 anymore. This is not so easy, but if you can see through that it's a perfect square trinomial, then we're in business. All we got to do is take the square root of 4x squared, which is 2x. We already know it. Take the square root of 49, which is 7. Make one copy, make another copy. And what do I put in between? Well, there was a minus here. So I put a minus and a minus. And what's going to say on your answer sheet in all probability? 2x minus 7 squared. Problem over. So this technique of a perfect square trinomial can help us with a harder situation, a harder problem. And there's one more thing that you need to know about factoring before we can really move on and see. I want to do it on this piece of paper, so I'm going to show it to you. I'm going to clutter this paper up, and I want to show you one more thing about factoring. and that is when you have something called the difference between two squares. X squared minus 100, factor it. Okay, there's a name for this. It's called the difference. The difference of, well, in short form, it's called the difference of squares. Let me show you what's going on here. Notice this. X squared is a perfect square. You can take the square root of x squared, you'll get an x. 100 is a perfect square. You take the square root of 100, you'll get 10, no change. X squared of x squared, x, no change. What's in between them? A minus sign, difference. Not a plus sign. The plus sign won't work. A minus sign. If you have these symptoms, this is a perfect square, this is a perfect square, and there's a minus in between, you're on easy street. Take the square root of x squared is x. Take the square root of 100, which is 10. Make two copies. But in one you put a plus, and another you put a minus. You can check that out. Just go do the FOIL and see that it'll get back to the beginning. And this is done. That is factored. So if I give you another problem, let's see if I can get the paper to change here. Okay, if I can take a second piece of paper without incident. Let's see if that's going to work. That'll be great if it does. Nope. Oh, there we go. Wait, how that happened. Okay, it's not working out. We'll have to do it on the next video. Actually, we can do it right here. We can do it right here. We have a little more time on our hands on this video. We can do it right here. Hold on. Not necessarily.